All right. I think it should be visible. All right, perfect. Yeah, so welcome back, everybody. This is our final workshop. And what we're actually going to start off with is a little bit of review and just concluding thoughts before we actually move on to going over logistic regression or the code for it. Here's the link to the slides. And I think either Nikhil or Vaishnavi, maybe you guys can put it in the chat as well. The attendance code today is the last attendance code. It's Denver. And I'm not sure if anybody is left trying to figure out what the pattern is for these attendance codes. I don't know, Vaishnavi, do you want to reveal it right now, what the pattern actually was? Or does it anyone want to?
You can give them like guesses, opportunities.
Yeah.
The hint was construction for the past attendance code, so if that helps you.
Again, people know what we're talking about. Oh, someone's saying something.
Yeah, so.
Yeah. Oh wait, you know, maybe I thought someone else interrupted me. I was just gonna say, if people don't know what we're talking about, there's a pattern in the attendance codes that we've had like the past 8 weeks, and so yeah, try to guess that. And, if you guys get it, I'd actually be really surprised. But no worries if you don't get it, because it's actually really niche, and I didn't get it either.
Okay, all right, we can go ahead and reveal it. Ben, feel free to explain.
Okay. So if I remember correctly, the pattern in attendance codes is it's the ranking of cities with the most number of construction cranes. And that's why the hint was something related to rankings and something related to construction. It was literally a ranking of number of construction cranes in the cities.
There's no disappointed in you guys, honestly, for not getting that. Kind of unfortunate. Yeah.
So easy, come on. All right, now we're actually going to move on. And what we want to do first is just kind of go over the material that we went over this quarter and kind of just do a little bit of review. I think in the, what's it called? The feedback form that we have for today's workshop, it's going to be one that we're asking for you for feedback about the whole workshop series. And the first question is actually asking you to kind of recall what is linear regression, or just kind of describe how it works. But yeah, we went over a lot of different topics for this quarter, ranging from like gradient descent, predicting continuous values for linear regression, classifying with logistic regression, using k-nearest neighbors for classification, and then using libraries like Numpy and Pandas to actually do machine learning and data analysis. And of course, these past 2 weeks, or just last week and this week, we've been implementing linear and logistic regression in in Numpy from first principles. Yeah, I think the link, the tiny URL link, should take you to the feedback form, and we'll give you a few minutes if you want to fill out that the first question. And then Nikhil will take it from there and talk about what you can do from here. Like after a beginner track, what else can you learn? Where can you go to learn more? What can you do with what you've learned? Yeah. Yeah, actually, while we're waiting, can anyone maybe talk about some of these topics that we've covered? Maybe I don't know, what's the best way to kind of go over this? What do you think, Nikhil? Do you have any ideas?
We have 6 people, and we have 6 topics, right? I guess the Numpy topic doesn't really count, but if you want, we can have if people are willing, each one person and talk about every single thing on this list really quick. Does that sound good? Or yeah, anyone who wants can answer, but it'd be awesome if everyone would hop in and either say something or type it in chat about each one. So I guess we can start with gradient descent. I mean, while you guys are writing the feedback form, first question stuff, anyone want to chime in on like what they remember about gradient descent and how it works and how awesome it is? It could be in chat or out loud. Yeah.
Yeah, I can tackle the first one. So I guess with gradient descent, it's kind of awesome to picture it as kind of a surface, like a cost function surface, and you start on like any hill, or you start anywhere, right? And then gradient descent's trying to find like the fastest way down that hill. So what it is kind of is you're finding the slope or kind of the direction, and you multiply it by a learning rate, which tells you how fast you're going to go down the hill and stuff. And then it's kind of like an iterative process where you start with one weight, calculate the cost, and then adjust your weight accordingly, and do that a lot of times to refine your answer. So
yeah, that was awesome. I like use the hill analogy as well. I guess the follow-up question I had real quick is you talked about it a bit, but what exactly does going down the hill like signify in terms of like your functions and stuff? Like what's going down or what's going up?
Yeah, I guess the z-axis would be your cost function, right? And then we only looked at it in 3 dimensions, so we only had 2 features, and kind of like where you are in that XY grid is the optimal feature, which is your weights.
Yeah. So you're minimizing. You're like you want to get like the perfect X and Y's, like the perfect features to get the best lowest cost. Yeah, exactly. Thanks, Austin. Perfect. All right. We'll try. If someone wants to, we can talk about linear regression. We talked about it a bit last week. Hopefully someone new would want to talk about it. If not, it's okay. But anyone want to talk about linear regression a bit, as well as like we learned about it? You can drop it in chat too if you don't feel like saying it out loud. And also, the longer we wait here, not if not different incentive. The longer we wait here, the more time we'll have to take to get to the logistic regression at the coding part. So, yeah. Oh, nice. We got 2 answers. Awesome. Thanks, Megan and Amin. Oh yeah. So, like you guys said, it's finding the equation that best fits, like the line of best fit, or like the equation that best fits a set of data to predict an output. So yeah, exactly. So you guys mentioned that your output is continuous. So yeah, it's continuous data set, and also your input can be varied, and so it's a big set of data, which is important. And some other things are the loss function that we use, which is in this case is mean squared error loss. So it's like figuring out the error by squaring the difference in the error, as well as our gradient descent is also really useful here, and our prediction function, our hypothesis function, which is like a linear function with weights and biases. Awesome. Unless you guys want to, I can just go through the rest of them or like go through them quickly. If you want to talk through them, feel free, but I'll go quickly. So logistic regression, we're gonna talk about today a bit more, write some code for it, but it's like linear regression, but we add like an extra layer on top to make it classify things. So instead of saying like this data predicts a score of like 102 out of 100, actually a really good score on a test. Instead, we're gonna be like this person passed the test or failed the test. So it's more of a classification thing. So this can be useful for different data types or like different problem statements. And then next, K nearest neighbors. This is near the beginning of the workshop series, but this is the way of basically given two sets of data, like given two classes, like a class of green triangles and red squares, figuring out, given like some data on like a new data point, what exactly is that data point? Is it a green square, a green triangle, or a red square? Figuring out that kind of thing. So it's also pretty cool and pretty useful. And if you want to go over it again, feel free to go back to our previous workshops. We talked about Numpy and Pandas, so a bit more. So Numpy is just like, Numpy epic computing stuff. Pandas is like data frames, so looking at data. And we talked about actually writing code for all these things. So we talked about logistic and linear regressions, writing code for them. So we talked about all that stuff this quarter. So great job, you guys, for getting through all of it. All right.
We can move on.
Oh, quick question about for the people, for everyone. How are you guys doing on like the first question of the feedback form? Are you guys almost good with the recalling linear regression stuff on the feedback form? A thumbs up and like Zoom would be great if you guys finish that. Or like in the chat also works, or anything. Or like a thumbs down. Oh, it's just no thumbs down. Like a shocked face in Zoom, or like not ready. Okay. No worries, Megan. We'll be still talking, so you can do it in the background while we're talking. But good to know. Thanks for letting us know. Hopefully, Amin and Candace, you guys are doing good too, or still working on it. So yeah. All right. So we did a lot of stuff. We're now gonna talk about what comes next. And so hopefully you guys like this workshop a lot. If you guys didn't, let us know in the feedback form why you didn't like it. But we started out this workshop series talking about shallow learning. So it's a lot like linear regression, logistic regression, but that's not it. It's also things like lasso regression, rich regression, PCA, principal component analysis, LDA, and other really cool techniques. And even though they're not as like, I don't know, as popular right now as like deep learning techniques for the for neural networks, they sometimes work better and also are usually faster to train. So they're still really important to learn. And side note is that if you guys want to write some more code about this by yourselves, feel free to look at our notebooks that we used for the past 2 weeks, as well as looking at a library called scikit-learn, also usually called sklearn because it's just easier to know. But it's really useful for a lot of things. We get some data sets from it, as well as just like a lot of cool methods and functions. So some general tips. Oh, and also, this is beginner track. There's also an advanced track next quarter. And so if you want to keep learning about machine learning and start learning about deep learning, which is really popular right now, really cool as well. We have a class about deep learning and neural networks called advanced track. And so that should be spring quarter because it's only winter quarter right now, but we'll be offering it in spring quarter. most likely. And it'll be talking about neural networks and a bunch of different types of neural networks. So if you're interested in those type of things, I'd recommend trying to attend or looking at the videos afterwards. And so really recommend that if you guys want to go into more detail on machine learning. And also, if you guys couldn't attend all of our beginner tracks because of time constraints or homework or all different types of things, we're going to be offering beginner tracks next quarter as well. So if you need a refresher or you couldn't be here all the time, that's a good opportunity to revise and come back.
All right. Yeah, I think we can move on to logistic regression now. We're gonna try this worksheet. I'm gonna give you guys a link to it. Project. And then there's actually gonna be two notebooks that we're gonna go through. This first one is gonna go through logistic regression, a simple like one-dimensional example, and then we're gonna do another example that extends that into multiple dimensions, similar to how we kind of did it last week as well. So I think we have few enough people that we're just gonna, we're gonna do breakout rooms, sorry.
We're doing breakout rooms, okay.
All right. Yeah, so we'll be going through this first one, and yeah, I'll see you guys in a bit.
Yeah, also quick thing, if you guys haven't finished the feedback form part for like the calling things, like calling linear regression, feel free to do it later or just submit what you have, or like just be content with what you have right now. But yeah, thanks for filling that part out. And yeah, see you guys in rooms. You can go to it.